Now we are doing balancing of locomotive. So I will be explaining what is balancing of locomotive. First I will explain configuration of the engine that we are using. Here all this formula are derived for this specific configuration. First, engine, the engine is like this like this. The piston is moving in horizontal direction. Suppose these are the tires, this are the tires, these are the tires, and there is a shaft. The and crank is like this. Piston moves in horizontal direction, and piston crank angle is theta. Here crank angle is 90 plus theta. We don't have to go in details. The distance between the two engines is a. There are two pistons used, and all the formula which are derived are for these two engines only. And for the specific configuration, when initial crank angle is theta and the initial crank angle is 90 plus theta. So this so after balancing, so we don't have to go in details. So when we do the balancing by balancing mass, what is left? Because we don't do 100% balancing, so what is left? Actually, I forgot to tell you something. In the previous one, we found this MRP, R omega square 1 minus C square cos square theta plus C square sin square theta. This was the unbalanced force that remained after the balancing. Initially, the unbalanced force was this, and the direction of this force is horizontal direction of piston. Now this the unbalanced force remained after somewhat a balancing. The direction is this. The direction is this. Some remains here, some remains here. So net direction is this. So we have converted a pure horizontal unbalancing force into somewhat horizontal and somewhat vertical. So this was what I forgot to tell you. Now in the same case in locomotive, when we do the balancing, some horizontal remains, some vertical remains. Okay, when we did the balancing, I will tell you the value of the this horizontal. The net unbalanced force which remained is in this direction, some horizontal, some vertical. So traction force, the unbalanced force in horizontal direction is called traction force. The formula is this, where Rp represents Mrp represents mass of the reciprocating mass. You have to take only mass of one piston, because let me remind you again, the formula is derived for both engines, means the total system it is derived. And after some calculation you get mrp. Mrp is mass of a piston. Don't multiply it by 2, it is mass of one piston only. We added something, we added the force of both, and later got the formula this. Mrp is the mass of piston, one piston, single piston, one piston. The configuration remains the same, two engine. This is mass of one piston. We consider piston mass same, both piston mass same, both crank radius same, both. Anyway, if the vehicle is moving with omega velocity, omega angular velocity, then both the engine will move with omega angular velocity only. C represents the amount of balancing we did, like 2/3 we balanced. Okay, and any day we completely balance the revolving unbalanced forces. So this is the unbalancing force remains in horizontal direction. Now you might be thinking the maximum traction force is this. At it appears as 135 and at 135 and 315 degree, because it's come as plus minus, plus at 135 minus at minus 135. Anyway, plus minus does not depends in magnitude, so maximum appears at 135 and 315. Now what I told you about the engine was like this. Piston was moving in horizontal direction, in the direction in which the vehicle is moving. So this traction force, I told it is in horizontal direction. Horizontal means here the any day the horizontal means the line of movement of piston. Any day, in any case, we what I talked. So here also it is along the piston, and piston is moving in the direction of vehicle. So in the direction or opposite, means in the x direction, mean which the vehicle is moving. So it is horizontal. It can be also called horizontal unbalanced force. Traction means track. Swaying couple. Swaying couple is produced due to unbalanced traction force only. So the formula for swaying couple is this, where A represents the distance between two engines. Maximum swaying couple is this, and it appears at 45 degree and 225 degree. Now I will say you what traction force and this both are side effect of balancing. Like we did somewhat balancing, some balancing remains. So this some balancing remains cause some effect. What are the effects? Traction force. Traction force is in horizontal direction. Sometimes the force can be positive x-axis in the direction of vehicle moving. Sometimes it can be opposite. So this traction force may sometimes help the vehicle to move faster, sometimes slows it down. So due to this, we feel a jerk in vehicle like this due to traction force. Now, what does swaying couple do? Swaying couple means a swaying couple in which plane the swaying couple is. Suppose this is the 3D figure. The tire are like this. The piston was moving in this direction. So swaying couple is in the plane of this horizontal plane. If we show you 3D figure, this so swaying couple tries to move the steering wheel, moves the steering left or right. So due to this, okay, now I told you about the effect of horizontal force, horizontal unbalanced force that remained. Horizontal unbalanced force will cause a force and a swaying couple. Swaying couple is side effect of traction force only. Now vertical unbalanced force which remained. Like we did balancing like this, so vertical sum remains. Initially purely it was just horizontal. Now we have converted the means horizontal. When I talk about horizontal in reciprocating or revolving reciprocating engine, horizontal means the axis of piston movement. So initially it was all piston side. Now we have converted some piston, some vertical, up down. Hammering action, the unbalanced vertical force that remained. Initially it was not there vertical force, but unbalanced, there was no vertical unbalancing. But as we did balancing of horizontal force, we have to deal with the vertical unbalanced force. Hammering action, the maximum vertical unbalanced force caused by the mass provided to balance the reciprocating forces. Hammering force is the maximum value. The maximum value is the value of hammering action is hammering force is C mrp r omega squares, where C represents the fraction that is balanced. Hammering force is direct proportional to omega of the locomotive. So if vehicle is moving very fast, then hammering action will be more. Traction force represent horizontal unbalanced force remained after some balancing is done. All these formulas are derived for the configuration which I showed you, and due to hammering action, the piston goes like the vehicle will sometimes lift, sometimes goes down, because any day first hammering means maximum. And if we are just talking about the vertical unbalance, here comes the sine theta. So sine theta can be positive, can be negative for some angles. So when it is positive, means it is hammering action is trying to push the wheels down, and when it is negative, the hammering action tries to pull the wheel up, means connection from the road is broken. Now the topic which I am discussing can be useful for solving question of mechanics. Load on each wheel, load on each wheel is sorry, load on each wheel, we are neglecting the weight of the wheel itself. We are neglecting the weight of the wheel. Suppose there are four wheels. Suppose I'm saying the configuration, just follow this configuration. There are four wheels, and four wheels, and there are two engines, just like I showed in locomotive, the exact same engines. The piston is moving horizontal and this is vertical. Vertical means crank is vertical, and here 90 plus theta, it's crank, means piston is both case vertical. So there are exact same engines as the locomotive which I described. So load on each wheel is equal to W by 4 in each wheel. Suppose this wheel, weight of the whole body divided by 4 plus hammering action नहीं, vertical hammering action is maximum vertical unbalance, but here not vertical maximum vertical, we are taking vertical, mrp omega square sine theta. So you can see sine theta can be sometimes positive if the theta represents the crank angle from IDC or from TDC. Inner dead center is equal to top dead center anyway. So this. So now the question can be asked like this. I have neglected the weight of the wheel. If you want the weight of the wheel, you can write the weight of the wheel. Okay. Load on each wheel. Load on each wheel is equal to load given by the ground, action reaction. So W by 4 plus vertical unbalanced force. If we neglect weight of the wheel, if we want to add, we can add, no problem here. So what I was saying, is suppose if the question is asked how much can be the maximum omega of the engine. So W by 4, this is downward force. Okay, so I have to just explain something. वर्टिकल अनबैलेंस, उसका इनिशियल डायरेक्शन डाउनवर्ड की तरफ है. अब वो डाउनवर्ड होगा, अपवर्ड हो गया, साइन थीटा पर डिपेंड करता है. तो एज आई रोड, तो इसका मतलब ये डाउनवर्ड है, इसको भी हम डाउनवर्ड अब कंसिडर कर रहे हैं. बट साइन थीटा जैसे चेंज होगा, इट कैन, दिस विल बी ऑलवेज डाउनवर्ड, दिस कैन गो अपवर्ड. इसका मीनिंग द हैमरिंग एक्शन कैन ट्राई टू लिफ्ट द व्हील. सो कब लिफ्ट करेगा, टेक द मैक्सिमम केस, साइन थीटा मैक्सिमम कब 1 होता है. सो CM/RP R ओमेगा स्क्वायर. सो ओमेगा इज इक्वल टू W by 4 वेट ऑफ द व्हील नहीं, वेट ऑफ द होल बॉडी डिवाइड बाय 4 CM/RP weight of the piston, mass of the piston R under root. More than this the speed cannot be, you should not go beyond this, otherwise there is a tendency of wheel to lift. Now MSQ question, 4 engines में perfectly balancing करना impossible है. 4 just now locomotive we deal with 2 engines, locomotive 2 engine we deal. Just now I told you about wheels, it is 2 engine. Now I am telling about MSQ questions. 4 wheel में perfectly बैलेंस करना इम्पॉसिबल. परफेक्टली बैलेंस का मीनिंग होता है प्राइमरी फोर्स सारी बैलेंस हो जाए, सेकेंडरी फोर्स सारी बैलेंस हो जाए, प्राइमरी का जो कपल है वो बैलेंस हो जाए, सेकेंडरी अनबैलेंस के द्वारा जो कपल प्रोड्यूस हो वो बैलेंस हो जाए, ये पॉसिबल नहीं. डोंट वरी अबाउट व्हाट द कपल ऑफ प्राइमरी एंड सेकेंडरी आर, जस्ट फॉरगेट. 4 it is not possible, 6 it is possible, 100% possible. That's why we use V6, V8, V12 engine, because in that engines we can perfectly balance primary unbalanced force, secondary unbalanced force, primary unbalanced couple, secondary unbalanced couple. One more thing, V engine, I will explain in the question.